In A-level math, for topics like integration, for topics like complex numbers, we will still be required to apply the trigonometric functions to the special angles 45 degrees, 60 degrees, 30 degrees. And in the secondary school, my teacher taught me a very easy way to recall this, and that is by drawing two triangles. The first triangle will be an equilateral triangle with sides 2. And for this equilateral triangle, I'm going to divide it into half from the apex to the base. So this is going to be 90 degrees. So if the sides are 2, that means here it is going to be divided into two parts, which is going to be 1 and 1. And because it is an equilateral triangle, we will be expecting this angle here to be 60 degrees. And because this line here is bisecting this angle, 60 divided by 2 gives me a 30 degrees here. And by applying the Pythagoras theorem, for this particular right-angled triangle here, we will take square root of 2 square minus 1 square, which gives me a square root of 3. So now based on this triangle, we can then quote sine of 60 degrees. Sine of 60 degrees is going to be equal to square root of 3 over 2. And we can quote cosine of 60 degrees, which is going to be 1 over 2. And then tangent of 60 degrees, which is going to be square root of 3 over 1. We can also use the same right-angled triangle here to deal with 30 degrees. So for sine 30 degrees, it is going to be equal to 1 over 2. And for cosine of 30 degrees, it is going to be square root of 3 over 2. And for tangent of 30 degrees, it is going to be 1 over square root of 3. And for 45 degrees, we are going to make use of a right-angled triangle with sides 1, 1. And that makes this angle here 45 degrees. Applying the Pythagoras theorem, square root of 1 square plus 1 square is going to give us square root of 2. So based on this triangle, now we can also quote sine of 45 degrees, which is 1 over square root of 2. Cosine 45 degrees, which is also 1 over square root of 2. And finally, tangent of 45 degrees, it is 1 over 1.